Hello and welcome back. Now we're going to talk about the direct pathway of the basal ganglia. And just to recap, when I have something in green, it's because it's excitatory to movement, and when it's in red, it's inhibitory to movement. We are not talking about neurotransmitters with that. We are just talking in general. If something is green, it excites the movement, and if it's in red, it inhibits movement. And then we'll discuss the individual neurotransmitters as we get to them. All right, so let's get started. So I like to call the direct pathway directly to movement, because that's what it does. The direct pathway leads directly to an enhancement in movement. Okay, so that is the overarching goal of this one. Okay, so how do we do this? All right, so let's start before we add in. Remember, we have our three players from the last video. We have our thalamus, we have our globus pallidus internus, and we have the putamen. That's our three players, because this is the direct pathway. There's no that humbo mumbo jumbo with all the other nuclei that we'll get in the indirect. This is the direct pathway. So we have just those three players that we saw in the beginning for now. We'll add in a little bit more here in a second. So how does the directly to movement pathway work? Okay, so let's start off with just the cortex. Nothing else. We're just going to start off with the cortex and how it influences this pathway. Okay, so to start with the cortex comes down, it sends projections to the putamen, because remember, we're starting in putting in bay. It all starts in putting in bay. We got to put our boat into bay. All right, so the cortex here is going to release glutamate on one of the receptors of those putamen cells. Okay, and you can see here that when glutamate binds, and in general, glutamate is an excitatory neurotransmitter. Now we're talking about neurotransmitters specifically. It is excitatory to that putamen cell. And that putamen cell then gets so excited, it goes ahead and it releases its neurotransmitter, which is GABA. And GABA in general is an inhibitory neurotransmitter. Again, talking about the neurotransmitter here. Okay? And then that transmitter gets sprinkled all over our globus pallidus internus. And that's good because, well, the globus pallidus internus, as we saw in the first video, it inhibits our thalamus. And remember, the thalamus, he's all about movement. He just wants to do movement. As you can see, he's got that big old green arrow up there. He wants to get the cortex going. He wants to get his movement. What the putamen does when it's activated from glutamate from the cortex is it releases its neurotransmitter GABA onto the globus pallidus internus. And so, essentially, it kind of just cancels it off. And now, the thalamus has its leash, so to speak, taken off of it, and it's ready to rup and roar, and it's ready to go out and excite movement. Okay? That's how that works. Now, let's see how dopamine influences this pathway. So, as always, we're talking about the neurotransmitter and the movement aspect differently. So here, we're going to have D1 cells. I'm sorry, not D1 cells, but D1 receptors. And you're like, well, you just pulled that out of nowhere. Not really. Look back up here at the directly to movement pathway. It's right here in the name. Directly, D1. See it? D1. Boom. I like that. And remember, I kind of think of D1 as M1. You know, we're all excited. We're all ready to go. All excited to be in medical school. And that's the purpose of D1. It's excitatory. And this is beautiful. Look at this. So, remember, we got to start with our gas station, the substantia nigra pars compacta. It's going to produce our dopamine. Comes over here and binds to the D1 receptor. And that D1 receptor, to the D1 receptor, it's activating that putamen cell. Remember, we just talked about that putamen cell. That putamen cell releases GABA. And so when it gets excited from that dopamine, it goes ahead, it sprinkles out its GABA, and it inhibits the globus pallidus internus. And now, boom, we take the leash back off the thalamus, we go back up to the cortex, we get our movement going. Isn't that beautiful? I just think that's beautiful. All right, so now we've covered dopamine, we covered glutamate coming from the cortex. Now there's one other thing. So basically, there's one other thing. Before I was going to say that. There's one other thing now. We got our acetylcholine that's always in the way of our movement. Always the guy in the car in front of us slowing us down. So we got acetylcholine coming here from the interneurons located around the putamen. So you can just think about these little neurons around the putamen cells. And they're coming up and they're releasing acetylcholine, which binds to the putamen cell. What does it do to the putamen cell? It inhibits the putamen cell. It shuts down the putamen cell. And that means no GABA gets sprinkled. GABA's gone. So what's that mean? Globus pallidus internus has its way. It's inhibiting our thalamus, going up to our cortex. We're not going to get movement. Shuts down the movement system. All right, we'll continue next with the indirect pathway.